All right, so thank you for coming. Apparently it wasn't as easy as it was supposed to be, and thank you for being here. We're going to talk about Kubernetes and what we learned in JFrog from migrating to Kubernetes. It's kind of an overview and intro talk, not like super hardcore, just best practices, things to think about, things to start talking about, this kind of stuff. So don't be misled by the title. It was kind of provocative by design, nothing too scary. So first of all, we start with why, and the question is why we even bother migrating to Kubernetes. It's easier to answer why you start a greenfield project with Kubernetes, because there's a lot of infrastructure and complicated aspects that are being taken care of for you. From migrating, there are different reasons. For us, one of the most important reasons were environment flexibility. What we do in JFrog, and I'm going to talk a little bit about that, is pretty complex in terms of the software composition, the deployment, etc. And we wanted make it easier on everybody to be able to deploy new environments, starting from developers, obviously, that want to, they write code in the need environments, also for QA, for support, for product, for solution engineering, doesn't matter, for everybody. That was where we kind of started, and we used different tools before. We used virtual machines, we used Vagrant, we used what's not, and when Kubernetes kind of started to catch up, we're like, okay, maybe this is our solution. Another thing that we wanted to do is a more efficient continuous integration and continuous delivery that will allow us to experiment more. If we can have more environment easily, which is kind of related to the first part, it's obviously benefits that because we can experiment more and do more fun things. And also save money and resources, because eventually we need to run our software in our cloud, because all our solutions are hybrid. You can download them and run them on your machines, on your servers, or you can consume them from us as software as a service. And when you do that, we pay for the infrastructure, and we want to pay less. And obviously, we want to use containers. We want to use a Docker to minimize the costs, and Kubernetes is a deployment platform that comes in mind. And also dog fooding. When you consume our software, we have, I think if I remember correctly, about 30 different installers and way to install. It's like standalone installers, Debians, RPMs, but also like Docker images and installers for different platforms. And also installers that allow you to run our software in Kubernetes. So we felt that we want to run our software in Kubernetes ourselves before we actually give it to someone else. So that's kind of the rationale behind it. And I want to start with the summary of what I'm going to talk about, kind of starting with the end. We're going to talk about how to start, and that actually this software is complex, so it makes a lot of sense to take it very easy in the beginning. We're going to talk about what you need to do with your application in order to get it ready for Kubernetes. We're going to talk about limits in life and in Kubernetes. And we're going to talk about different types of probes and why we need them, observability, here comes signal effects, and about a little bit about Kubernetes community. So that's kind of the agenda, but also the summary. Very easy slide reuse. I like that. And with that, so my name is Baruch. I'm Chief Sticker Officer, and also Head of Developer Relations with JFrog. That's actually my real business card. Here it is. I'm not. And it's obviously a sticker, right? Yeah, talking about the important stuff, which is stickers and t-shirts. They're over there on the table, and you should grab a bunch of stickers and a t-shirt. This is the t-shirt. I don't know how you feel about Daenerys in Game of Thrones after this Sunday.
It's more ironic than ever.
right? We think about maybe doing another t-shirt, but we need to get rid of those first, so grab a t-shirt. And stickers and what's not. My Twitter handle doesn't work. Here we go. My Twitter handle is @jbaruch. Feel free to follow me, as you already figured out. I'm very entertaining guy, so you should follow me right now. And also praise this talk on Twitter. This is also very important. The email is there as well. If you still not convinced about following me conveniently, my Twitter handle is on every slide. So whenever you decide, it's not too late. Okay, this is a great visualization of cultural differences across the world. And this is from the book called The Culture Map by Irene Meyer. And as you can see, the most emotionally expressive and confrontational two cultures are Israel and Russia. And I'm from both. So expect to be offended. And I'm kind of sorry, not sorry about that. And if I didn't manage to offend you during the talk, there is always time for questions that we can try another time. So anyway, I apologize if I do offend someone. It wasn't on purpose. Maybe it will. The most important slide of this presentation is this one. If you want to take a picture, that's the slide. I prepared a special landing page for you at jfrog.com/show-notes, and the slides are already there. The video, one of those two, should probably record, so I will be able to probably upload it tonight from my hotel, and you will have the video by tomorrow. All the links, everything I mentioned, including even the cultural map from Irene Meyer, is already there, so you don't need to take notes or pictures. It's all there. Place to comment, place to rate the talk, and also a small raffle for thank you for being there. It's an Amazon Echo Dot. You are not a lot of people, only 33, that's for the camera, so you have a very good chance of winning. Go there and fill the raffle, okay? Yeah. So, yeah, and as I mentioned, my Twitter handle is on every slide, but also the link to show notes on every slide, so if you forget, don't worry, it's right there. I have no idea whether you have or not this hashtag, but I think we should have. So now when you go on Twitter and tweet about this talk, use that dialogue as a hashtag. And we'll see it trending. So many people totally can do that. All right. So with that, let's start talking about Kubernetes. So a lot of talks and a lot of material is pure marketing bullshit. And they promise you this with Kubernetes, everything is working out of the box, you get the scaling, you get the resource optimization, everything is stateless, we can utilize the resources, but actually it's much more of that. It's a very complex machinery that does all what it promised, but it comes with the cost. You need to understand what you are doing. And Kubernetes is not the simplest of frameworks or deployment platforms to work with. And I will try to share with you some of the things that we learned that you need to be aware of when you jump heads first into Kubernetes. So start small. There are a lot of tutorials on Kubernetes, both official and unofficial, and all of them are good. Most of them are good. And you really should follow them. You really should start playing with it. And probably one of the first things that you are going to do, you are going to deploy Nginx into Kubernetes, and you will see this page, and you're like, yeah, I'm ready. Not really. So don't skip the tutorials, even if they look banal and simple to you. Really do them, because this is how you learn. And the official resources are pretty good. I have to say here that if you go to show notes and you look through the links, you will discover that a lot of them actually come from the Microsoft Azure developer relations team. In the last couple of years, they do amazing job in giving developers help in everything that is related to Azure. And obviously, their Kubernetes offering is one of the three, the biggest ones. So use that. Use their resources. They are really good, and they did tons of good work for us. And speaking about Azure and other cloud offerings for deploying Kubernetes, use them as well. When you start, don't try to roll out your own Kubernetes, even if in the end of the day you have requirements of running Kubernetes on premise, still start with the cloud providers, because they abstract a lot of complexity and a lot of aspects that if you will be exposed with them from day one, it will be just overwhelming. So you start with them, and it's much easier. And as I mentioned, they also have guides, they have help, they have a lot of services provided for you. So it's a really, really good idea to start with one of the three providers. We run on all three of them, and we don't have a special preference, so I cannot suggest you one on top of the other. I think all three of them are very good. Google was first, they are the most mature. Amazon Web Services is kind of still standard de facto for SaaS platforms. And Azure, as I mentioned, have a great team of developer advocates that really try to help the developers learning the technology. Yes?
You know, Docker Desktop has been including Kubernetes.
Yes.
Is that taking away some of the struggle?
Yeah, absolutely. So Docker for Desktop for a while now, it comes with Kubernetes built in, and that replaces an older tool that we all use to mimic real Kubernetes cluster on our machine, Minikube. Now we don't need it anymore, and it works. It's of course a good way to start, but in the end of the day, what you want to practice is actual deployment, and that you do in a proper Kubernetes service. You will probably use your Kubernetes anyway to run on your desktop environment, but it doesn't replace like deploying the real thing.
Yeah. Can you expand the relationship between Docker and Kubernetes?
Oh yeah, absolutely. So Kubernetes is think about it as a platform for deploying Docker images. Right? At the end of the day, the idea is that you have a Docker image that you want to run somewhere. And Kubernetes is the framework that allows you to run a lot of Docker images or Docker containers, and they know how to talk to each other, they know how to scale up, they know how to scale down, this kind of stuff.
They call it orchestration, I think.
Yeah, that's the term, orchestration, right? They orchestrate Docker containers. Does it make sense?
So before Kubernetes, it was just a Docker.
Yeah.
How did you do it?
So you had some kind of orchestration.
Docker Compose.
Docker Compose. Swarm. Actually, Swarm.
DCOS.
Compose was for another purpose. Swarm is Docker official orchestration before Kubernetes. Mesosphere. DCOS was another one. There was a bunch of others, but in the end of the day, Kubernetes kind of won. Everybody do Kubernetes now. It's kind of standard de facto. That's the default orchestrator. And does it make sense? I probably should have done some kind of overview of how it works, but I think that's...
We just like interrupting. It's fine. We just like interrupting. It's fine.
No, that's fine that you are interrupting because we are in the intimate atmosphere, so interruptions are fine.
Nice.
And if you hear me saying some terminology that you don't understand, just ask me. Okay. So another great tool to start with Kubernetes called Draft. And again, speaking about the developer relations team of Azure that came with that, that's another one of their great tools. Draft, it's a tool that you run inside your Git repository, and whatever code is there is now ready to run in Kubernetes.
Really?
It's like magic. So the way it works is they have those specs for different languages that they recognize what language your code is, and then they take the right template for the right language, and they know how to build a Docker file for it, and then Kubernetes template for it. So obviously it won't work on a super complicated code basis, but to getting started, this is gold. So basically when you want to start with your hello world and try to Kubernetize it, this is what you do. You run hello world in whatever language you want to run it, then you run draft, and then you look what you ended up with. And you will see, this is a Docker file, it builds my Docker container. And this is the Kubernetes resource that was created in YAML, and this is how it is used, and you can see how it all works together, and it's actually deployable. You can go ahead and deploy whatever draft created directly to one of the Kubernetes platforms and see it running, and that's obviously a great way to get started. Okay? Yeah, so definitely take a look at draft. This is a great way to get started. Will it be able to Kubernetize your 20 years old legacy application that contains million lines of code? Probably not. But when you start playing with Kubernetes and you want to understand how it works, this is a great resource. Okay? So once you get familiar with Kubernetes and you know more or less, you got the feel of it and you understand how you run your hello world on Kubernetes, and you're like, I think I start getting it, that's the time to take a look at your application. And the chances are your application is not ready to run out of the box on Kubernetes. There are a couple of aspects. The one that is overlooked a lot of times is how do you do logging, right? So Google logging best practices, one of the anti-pattern that you will find is using standard output. Everybody tell you don't do that because you lose the ability to save it, to search through it, you lose the appenders, blah, blah, blah. Forget about all that. The only way you do logging is Kubernetes is through standard out and standard error. Because that's the only thing that Kubernetes knows how to collect and how to output either to your command line, which you can use, or through logging tools, cloud-native logging tools for Kubernetes, like FluentD that we're going to mention in the future. So basically, yes, all the logging now should actually go to standard out and standard error. And it's kind of a little bit counterintuitive, but that's what you are doing. It also helps because in the end of the day you have multiple containers running Kubernetes, and if you just output everything to standard out, Kubernetes will take care of gathering it all together and actually giving you access to it. So this is how you do it. Another very important aspect is data persistence. Now, in the perfect world, your Kubernetes application should be stateless. That's kind of the holy grail of cloud-native applications. Cloud-native applications should be stateless by default. You'll probably say, no, but I need my state. But do you really need your state? You need to think about it very good, because in a second you get into persisting state with Kubernetes, you are on a completely different level of complexity. You need to start dealing with reserving data mounts, and then, so one of the things of Kubernetes, and I'm going to mention that again and again, is that your application will be killed, like a lot, like all the time. To scale up, to scale down, to migrate between VMs, to migrate between nodes, it will be killed all the time. And then it will be restarted, which is fine, and the question is, how all this, how your data persistency survives that. There are solutions as of today, and the stuff that we do is actually about saving files. We don't have any other way to go except of persisting state, but that adds complexity, and if you can do a stateless application, that you will be in a much better place. Yeah, so talking about reviving from the dead, be like this guy that I keep forgetting his name. your application will be killed a lot. It will be killed every time it misbehaves. It will be killed every time you're scaling down. It will be killed every time your Kubernetes provider decides it will be cheaper for them to run your containers on a different physical machine or virtual machine.
So who's the Lord of Light in that situation?
Kubernetes. Kubernetes.
Right.
Yeah. That's very true. Because Kubernetes is going to kill them, but it's also going to revive them in other places. And you will get a lot of that. And your application should be able to gracefully die and, not to keep garbage and clean after itself, but also be able to restart very fast on demand. This is very important. If your application starts for a very long time, your scalability will be limited because all these dents won't be available. And I'll tell you what, if you have a good Kubernetes citizen that knows how to die gracefully and then how to get up very fast, you'll be able to save a lot of money because all the providers have this concept of preemptive VMs, which are, we won't guarantee any uptime for a single node, and if you can live with that, you will pay like a third of a normal price. But your application, this node of your application, can die in any second. We will guarantee that you have all the scaling requirements that you want. And if you require, for example, 3 instances of a certain service running in all times, we will respect that. But each and every one of them can die in any time and then be started up in a different virtual machine, a different node. And this is how you save a lot of money if you can do that. So this is very important. What else? So high availability with Kubernetes relies on those concepts, relies on the fact that you are as stateless as possible, and you can always start up very fast and join the cluster of everything else. And that's completely different from the concepts of high availability we used before, right? They were the opposite. We will survive any attempt to kill us because that's what highly available means. And that's exactly the opposite. That's completely different mindset. And if you did that before, you'll probably have to rethink it and rewrite it to this concept. And scaling. Up and down all the time, nodes are coming up, nodes are going down. This dance is, with Kubernetes, is going to happen all the time. Upgrades and downgrades, rolling upgrades and zero uptime upgrades and downgrades are a reality as well in Kubernetes. When you want to upgrade something and you have 3 nodes, they will be upgraded one after another. And then that means that some of the pods and a pod is a unit that runs your Docker container. So some of the pods will be newer or older than other. And that's a requirement from your application to be able to know how to handle it. For example, if you removed a REST API endpoint, you need to remember that old pods will still try to access it because they don't know that it was removed because they are from a previous version. So, sorry, it's not something that it is impossible to do. I'll tell you more. In JFrog we have this vision that it's called liquid software, and liquid software has a lot of traits in common with Kubernetes in this regard, that we believe that the updates should flow almost like water all the time, right? When you write something, there is no version, there is no build, there is no a version build or product build. It's all continuous. Continuous updates are flowing all the time, and this concept of rolling upgrades and downgrades, zero-time upgrades and downgrades has a very central place in Liquid Software as well. So in our book, Liquid Software, we actually talk about very practical advices on how to do that. And if you are interested, feel free to take a look there as well. We talk about exactly that concept. All the requirements from a cloud-native application, that it's basically the requirements for Kubernetes, are summarized very well in the 12 factors application manifesto. And there is a website, and you know where to find the links, at JFrog.com/show notes, that spells out the 12 factors of a proper application. And you can see here you can see here some of the aspects that we already spoke about, some logs and the dev and prod parity. We're going to talk about that, and this is how you build your environment, so you will have a confidence that what you have through the pipeline actually matches what you have in prod. We're going to talk about that. Disposability, right? This is how everything got killed and everything still works, etc., etc. So there are a lot of factors that it's an easy read, and it actually gives you a very good guideline on how to do that. Highly recommended resource. Okay, so now you know what Kubernetes is. You played with this. You've done your tutorials, and you kind of looked at your application, and you know how to prepare it to Kubernetes. Now let's look at Kubernetes itself. The stuff that might be a little bit less trivial when you did your tutorials on what actually you need to remember. So first of all, very, very important are the limits. And limits are critical because this is what instructs your Kubernetes provider on what to do, which resources you need, and what to do when you hit the limits that you describe. And what will actually happen when you hit those limits will be auto-scaling. You will get more resources for your application, but you need to tell Kubernetes this is when it should happen. And you can see here that you can have two types of limits: the requests and the limits. The limits are bigger. The request is this is where you should scale up. This is the request. And limits, this is the virtual machine that I need, or part of the virtual machine, like part of the pod that we actually need. And this is kind of a common knowledge. Everybody knows that everything should be limited in Kubernetes. What you need to remember is that your application should have matching limits as well. So, for example, in Java, you need to set the maximum and minimum heap sizes, and with RabbitMQ, you need to set what is the total memory cache size that you can use on the disk. So you basically need to remember that those limits should match, because otherwise bad thing happens. Obviously, they need to be coordinated. Another very, very important concept of Kubernetes that you might use even outside of it, but not necessarily, are the probes. The probes are the way for Kubernetes to heal itself. This is how Kubernetes knows if everything okay with your application. And there are two kinds of probes. There is a readiness probe, which says to Kubernetes, this is when we can start routing requests to the new member of our cluster. Right? So we hit the limit, we decided we need to scale up. There is new node coming up, it has the new pod on it. And once the readiness probe returns that everything is fine, it means that we can start putting traffic through to our new node. The other type of probe is liveness probe. And this is the self-healing of Kubernetes, using that to ping your application once in a while and check that everything is good. The second liveness probe misbehaves, either returns no, everything goes not okay, or just disappears, that's the signal for Kubernetes to kill this pod and fire up another pod instead. Then hopefully won't have this problem. And this is how the automatic restart works, and it allows us, obviously, more robust applications without human intervention. There are 3 types of probes, and both for both of them, both for readiness and for liveness. The exec, which is an application that, by the best practices, should return code 0 when everything okay. HTTP probe, which should return an HTTP status of under 400. Basically, it will be like 200 okay, and that means that it's fine. And the TCP probe, which we'll consider okay if we manage to open a port to a certain port that's defined. And then you go and you define your probes, and you say, okay, readiness probe is of type of HTTP. This is the URL that we need to ping, and that's actually a REST API over factory, API system health, and port and NA80. And that's an example of an exec probe. We run Mongo eval and Mongo dbadmin command ping, and we expect 0 in return. And TCP sockets that try to open this. Now, if your application doesn't have a built-in probe or like ping REST API, probably the easiest way is to write a shell bench that will return 0 if everything is correct. You inside you do the checks that you want, but generally, if you have a REST API on your service, having this health check is always a good idea. And how deep this health check, it's up to you. You can try and decide to check every possible system in this check, or just minimal smoke test that everything is up and running. But it's very good to have anyway. And with Kubernetes, you will actually have to do that in any case. Okay. Now, another concept that is very, very popular is the relationship between the pod and the container. So, I would say the default out-of-the-box relationship is a single container in the pod. It's this single single responsibility principle. When you have your microservices, each microservice does only one thing. Each microservice runs in its own container, and each container runs its own pod. This is kind of the default thing. Sometimes you want more than one container in pod, and the examples could be you need something to run before your container actually is up, stuff like preheating your cache or running configuration scripts, but that's probably not the right way to have your application started in the first place. It can be like kind of a legacy and migration phase, but the real proper use for this scenario of more than one container in pod is what it's called the sidecar design pod. And the sidecar is like with a motorcycle, you have your main vehicle, and then a sidecar is having a container that does some kind of a service for your main container. For example, it collects the logs, and a lot of log analyzers, a lot of tools that do log analyzing like Splunk and Sumo Logic, all those, they actually require you to run a sidecar container with each and every of your container to be able to collect the logs and then send them to their central processing, etc. Monitoring is another example, or I think the most known usage of the sidecar is a network proxy or network mesh implementations like Istio. So if you ever heard of Istio, this is how it's done. It's a container that sits with your container and manages all the aspects of its networking through it. And you can do it with Nginx or Okay, so now let's talk about the deployment pains with Kubernetes. So how do you deploy anything in Kubernetes? You find the YAML file in the internet that you think fits what you want to do, and then you copy it and then you paste it, and then you fix the indents in YAML, and then you repeat endlessly.
The Stack Overflow pattern.
Yeah. But I think the most annoying part here are the indents with YAML. And then you repeat. And that's obviously super annoying. This is an example of Kubernetes resource. We have some Docker app 1.0 that we just deployed. It's running Kubernetes, and now we actually build a new Docker app of version 1.1. And everything is good, but the only thing is we need to go ahead and change the version of our container in the YAML. So there are many ugly ways to do that. You can do sed, and then find it by a regular expression and replace it, and that's not fun. There are a lot of templating engines for YAML, both homegrown and kind of open source. All of them are pretty ugly and broken. Or, you can do latest. Not really. You shouldn't do latest. Anyway, that's a different topic for the entire talk about how awful using latest is.
I mean, so long as you control what you push to latest, it should be okay.
And this, as long as, usually never happens. So that's exactly where the problem is. Anyway, we have a better way to do it. And the better way to do it is called Helm. Helm is encapsulate. It's a package manager for Kubernetes that allows us to run encapsulated packages of Kubernetes deployments. So instead of having all those like 1, 2, 3, 4, 5 different YAML deployment files that we need to copy paste from the internet and deploy if we want JFrog X-Ray to run on our machine, now we have just this encapsulated unit that is called X-Ray Helm chart that we use Helm to run, and it will take care of everything. Now, we in JFrog are very big fans of X-Ray, of Helm. One of Helm core committers works at JFrog, and there are actually a sticker of a frog holding a helm over there, so that's kind of our thing. By the way, the majority of Helm committers work in Microsoft again, in talking about the Azure team and what they do, so thanks Microsoft for that as well. Another very powerful feature of Helm is the templating of the descriptor files, and this is where, this is how we get rid of the sed and the latest. You can just change it using a values file, and then you all you need to do is replace the values in the values file. Right? The Helm itself as a dependency manager is very simple. You can see here an example of a Helm chart deployed into Artifactory, into JFrog Artifactory. I'm going to talk about that in a second, but this is how it looks like. You have an archive, and inside you have a bunch of templates templated with everything that needs to be templated, and then there is the values YAML file with the values, and you can have multiple values files based on your environment, obviously, and then index that lists all the Helm charts that you have. Super easy. Right? And using templates, we can reuse charts for multiple image versions, right? So you can have one Helm chart that will correspond to multiple versions of the Docker images inside, and they have their own versioning, and then it's kind of the chart is the bigger picture, the one layer up that contains all of them inside. And there is a central repository for a Helm chart. It's called kubeapps.org or something, and then that's a very, very old screenshot. They have thousands of Helm charts over there when you can search, and they give you exactly what to do, and this is a very, very nice way to install it. Here, kubeapps.com. That's the official repository. You should have your own Helm repository, both for deploying your own Helm charts and also for proxying the Helm charts that you use. you need to have your own Docker registry, you need to have your own NPM registry, Maven repository, and everything else. And as I mentioned, the Helm structure is super simple. You just run an HTTP server that serves this index YAML, and then you can run it every time everything changes. That's a pretty stupid thing to do because that's a lot of maintenance for a thing that you don't want to maintain. Instead, you can use something like JFrog Artifactory, which is a universal artifact repository that supports Helm, but also Docker images, and pretty much everything else. Regardless of what type of development you do, you'll probably find it supported in JFrog Artifactory. This is what we do. And give it a try. Another very important concept is observability. And as I mentioned, a lot of things are going on, and the things that are going on are kind of encapsulated into new types of abstractions that you might not be very useful to do. Right? So the way system administrators always observe their applications was SSHing into a machine and then grabbing in logs. You don't need to do it anymore. It's also not very easy to do anymore because, as I mentioned, your application now runs in different pods, in different nodes, all across your provider virtual machines. You don't have an easy access to them in the first place, and also there are a lot of them. Each of them have some parts of your logs. It's basically impossible to do it the old way. You don't want to do it, and you cannot do it anyway. Right? So, more so, with this approach, you don't need to give an access to production to everybody, unless you pretend you are Netflix. By the way, you are not, so don't even.
Why does Netflix get to do it?
One of the biggest things that Nexus brags about is how every developer has access to production. And they think it's a good idea.
Etsy did too.
Yeah.
It's a good idea until someone screws up.
And that someone usually screws up. Yeah.
Usually when you have that type of system, you just have a ton of monitoring. And as soon as something is a blip, whatever was deployed is reversed.
Yeah, that's true. I think it has to do with the trust a lot. And we want...
Yeah, they also have the whole chaos monkey.
Yeah. No, but that's something else. Chaos monkeys try to pretend there is a catastrophic failure. Mm-hmm. And that's not necessarily what people that have no idea what they are doing can do when they have access to production.
I mean, that's one part of the simulation.
Yeah.
There are many parts of it, I think.
Absolutely. Yes, I agree.
Yeah,
So,
buy Casey's tiny little book and give him his 10 cents.
Yeah. Anyway, I don't have an opinion on whether it's a good idea or not. I think it might be a good idea in some scenarios and might not be a good idea in others. If you have federal regulations on your head, and instead of just running a video streaming service that worst case scenario will go and watch YouTube instead, you run a network of ATMs. I don't know if you really want to do that. But either way, you don't have to. Because you have observability tools, stuff like logging aggregation, stuff, and there are a lot of providers, and everybody now work with Kubernetes, usually by installing their Sidecar.
It's really default for each cloud provider too, right?
Yes, obviously when you run on cloud providers, they have their own.
Yeah.
So each of the platforms have their own logging systems that know how to collect the logs, but if you want to use third party, Synology, Splunk, Log Entries, tons of others are all good options. APM, Application Performance Monitoring. This is not exactly observability because the goal of APM tools are providing you performance metrics, but again, if something goes horribly wrong, obviously APM tools will alert you as well, and monitoring, observability monitoring tools like Datadogs and SignalFX. Yay!
There
Yeah, actually,
IBM too. So,
yeah.
but
They're hiring, they're awesome. Their executive VP of engineering is a dear friend of mine. Leonid, we love you, you're cool. Yeah, so SignalFX are dear friends. Yeah, use them. Cloud native tools?
Can I just ask you about the logs? Because this
Yes.
is a very problematic. We need to be able to look really detailed into the log.
Absolutely.
Just-
Yeah.
and
You'll
I
have more
tried to-
detail.
Huh?
You'll have more detail than you did before.
Yeah.
No, I'm saying Splunk is not good enough for this. It's like looking through some kind of a very. I can get the whole log.
Yeah, absolutely. In each and every one of them, including Splunk.
Yeah.
Absolutely. Yes.
Can I just retrieve them into my local?
Yes, but it's probably that much that you don't want to do that. Again, we're talking about highly scalable systems that run in the same time on different nodes, and the aggregated log probably in some point of time will be useless for human processing anyway. It's not like your hello world that you look at the log and you're like, oh, okay, that makes sense, or this is something wrong. Usually when we talk here about the log, scales of log that can be processed probably only through queries in like query language, like Splunk query language and Sumo Logic, they all have their own query languages. Or more than logs, you will rely on actually monitoring. Because monitoring, so logs are reactive, right? You look at the logs once something happened. Monitoring gives you real-time information on what's happening. And I'm doing the SignalFX speech good
yeah,
enough?
no, this is great. I mean, I would say the only thing that I would add is the difference that we always talk about with true observability is having some measure of all three. So the log data, obviously, and then the APM, the traces from the applications, and the metrics from the infrastructure. And that's when you really have it all. I think just the system looks good.
Datadog can do APM as well, by the way.
They all do like Pur's man APM because the metrics can give you hints about
And also log aggregation. Datadog can correlate events to logs.
So all three of them are kind of doing the same thing. You can do performance monitoring from the logs. You can do a little bit of monitoring from the logs, or you can actually have alerts from APM. They are not the same. They all have different purposes, and you will probably sooner or later end up with all three of them. You can start with, I don't know, with probably each and every of them and give some parts of others, but it's better to use the right tool for the job anyway. Well, I mean, you can do APM for monitoring, but you won't get end-to-end transactions
But if
monitoring.
you do have log aggregation, but what Datadog can do is like, say you get an alert that your CPU load is high or your memory load is high.
Yep.
You can then have logs that correlate to that event that get dumped, and then you can see, okay, this application was doing this here.
But that's still not a true APM. True
Also,
APM
if
are
you're
metrics.
at Dev Dialogue, if you're going to shill for a company, we expect some swag. So
Yeah, right?
What happened?
Right?
if you're going to,
Where's the Datadog swag?
Oh, here you go. We came ready.
Oh, here we go. There you go.
Yeah.
I'm just saying, yeah.
No, we're just
Are you
giving
working for Datadog?
No, I'm not.
No, we're just giving you shit for fun with.
I think they're open source software program.
Yeah, none of them is 100% replacement for each other.
Oh no, I'm not saying like none of them. Like all of them have their places.
Exactly.
But like Datadog can kind of do everything.
You want to say monitoring instead of Datadog because you don't want to piss these
I
guys.
mean, no, it's totally fine. And honestly, Datadog is a great company. We compete against them all the time, and we win all the time.
Are you customers yet?
What, of them?
Or,
No,
or
that's
vice
our-
versa?
That's our biggest competitor.
Yeah.
The market has realized.
Now I'm curious if someone from Datadog actually showed up.
Yeah. I mean,
Yeah, no, they both great guys, Datadog and SignalFX, and yeah. So
I've not gotten access to log aggregation because they haven't given it to the free open source software program.
Yeah, so anyway, use signal facts. And, yeah. There are a bunch of cloud native tools that were created together with Kubernetes or specifically for Kubernetes to do some of those aspects. So, for example, for monitoring, you can use tools like Prometheus and Grafana and get visualization on what's going on. And for logging, there is the ELK stack, which is kind of a replacement for the ELK stack. ELK stack stands for Elasticsearch, which does the search, Logstash, which collects the logs, and Kibana, which does the visualization of the logs. So since we spoke about how logs are collected differently in cloud-native applications in Kubernetes, instead of streaming them to log collectors, we dump everything to system out, and then tools, cloud-native tools like FluentD know how to collect them. In the ELK stack, we replace the log collector to a cloud-native log collector, and Elasticsearch, FluentD, and Kibana gives you a very nice open source and free log stack to start with. You might want to switch to something more heavy like Splunk or Sumo Logic down the road, but this does the job at least for us.
You have the
You must need to
problem.
monitor if you don't do it yourself.
Yeah.
You have the problem with those dashboards too is exposing them to the proper stakeholders and also providing a mechanism for them to make new visualizations, etc. That can be a little daunting.
Mm-hmm. Yeah, that's right. So another thing that we do, and that was one of the original reasons we started with trying to come to Kubernetes for all things, is those promotion concepts that provide us with staging, with dev prod parity. This is how we manage from one side to have a lean development environments that are easy to do experiments on, to do feature talks, to build some weird branches of continuous integration, but in the end of the day, have confidence that we know exactly what runs in production. And this is done with pipelines and promotion concepts. What's interesting here is that, okay, you have your source files, you build them in the CI server, and starting from them, you have a set of environments that run a little bit different configuration, and it goes closer and closer and closer to production. Actually, I have 5, and when those are the quality gates that your software needs to pass in order to be promoted to the next environment. And the promotion itself is done in your artifact repository manager in stuff like JFrog Factory, that hence the logo. When you actually, what is happening is you have your artifacts here, you install them on your environment, you do what you need to do, automated testing, manual QA, experiments, get a look and feel on how it works, and if everything's good, you promote it to the next one. Next one is closer to the real deal. It will probably maybe start a little bit slower and have more of the data inside and what's not. And if that passes, you pass it all in all the way that you get to production. This is what we do. This is what we preach. It works exceptionally well for both us and our 5,000 customers. So definitely, this allows you to be lean and experimenting from one side, but having a very close to production staging environment on the other side. And obviously it all goes with the CI server. We use Jenkins. Some call us auto parts for it. There are different tools today, both cloud native, run in cloud, built for Kubernetes, like Jenkins X and tons of others. Recently, we acquired a company that does CI that is called Shippable. So we look for actually now having our own CI service in the JFrog stack as well, But for now, we do use Jenkins for our builds, and you can see here how those environments are, how all the pipelines are being promoted and then actually being deployed in different areas: Australia, India, the US. At some of them only in 2 places. Some checks are actually skipped and what's not. Very, very flexible stuff.
I know that GitLab and Bitbucket now give you pipelines built in, just configurable with YAML. You can pull in your own containers, publish your own containers, and also run all the tests and do promotion tests.
Yeah, absolutely. So the pipelines, basically, the pipelines is nothing complicated, because in the end of the day, what you need to have are just enough environments. But this part, when you actually propagate your artifacts through pipelines, it's a little bit more complicated. And some companies preach that you don't need it. You can rebuild in each and every environment. And from our experience, we can guarantee you that it doesn't work. In some point of time, you will have different build, and in some point of time, you will end up in production with something that you didn't expect to be there.
So you don't advise like living with that? You don't advise starting with that?
Well, I mean, what we say is, once you build your binary here in the CI server, take this binary all the way to production.
Okay.
That's what we preach. And for that, you obviously need a place to promote those binaries, and this is what we do as well. All right, and this is what it works. Right, so what we achieved so far, and when we are, half a year ago, we actually introduced our first Kubernetes first application. It's called Go Center.io, and it's a central repository for Go modules. Recently, Go came up with proper dependency management, and we were obviously the first to jump on this bandwagon. So if you now need a place to retrieve the Go modules from, this is what we have. Although it's backed up in Artifactory in the end of the day, all the rest of the application is purely Kubernetes, and actually Kubernetes first. We also, as I mentioned, distribute our software as Helm charts ready to be deployed to Kubernetes, and we use those Helm charts also at home for development and testing, and actually running them in production is also not very far away. So, one of the best resources in Kubernetes is the Kubernetes community. Because probably someone already had the problem that you have, and Stack Overflow is a great place to start. There are a bunch of Slack teams that are ready to help. The Kubernetes official Slack of Kubernetes is obviously super active. You can always ask there. CNCF ambassadors. Cloud Native Foundation is the foundation that Kubernetes is part of. They have a developer relations program that's called CNCF Ambassador. I'm one of them. Obviously our job is to help you to get started with Kubernetes or to solve your problems. And I think I'm the only CNCF ambassador who is not in Barcelona today, where KubeCon is taking place.
That's right.
Yeah. And instead I'm here with you, so I think I'm even more useful. There are a lot of them there, and I'm here with you. Project maintainers and committers are usually very, very helpful. We have a very successful experience working with RabbitMQ and MongoDB, Bitnami as the MongoDB provider, when we actually solved our problems in deploying their services on Kubernetes using them. So it's a proven way to get help working with the community, and we highly recommend you doing that. And now remember this slide. That's now truly the end. Right, so take it easy, start with something simple. Use the tools that are out of the box, both the tools that generate all the stuff for you and the tools that take away of the headache, like the cloud providers. Make sure that your application is ready, everything that we spoke about. Don't forget the limits and their matching. Don't forget that you have to have props, although it's a good idea to have them anyway. Observability is extremely important. All three ways of that, and use the community for your help. With that, show notes, don't forget going that. At JFrog on Twitter, now you know for sure that you should follow. And when you tweet about this, let's make the hash dev dialogue hashtag a real thing, and Kubernetes, that's their hashtag as well. Thank you very much. Questions?
When you guys were building the module repo for Go,
Go Center, yep.
yeah, have they instituted the whole versioning as part of the language?
You know what's the difference between good question and great question? So, good question is the question that I know the answer for.
Sure.
Great question is a question that I have a slide for, and I'm really not sure how should I call a question that I have an entire slide deck for. Right, so yesterday...
Excellent.
A plant? Not.
Yeah, I didn't pay. Yesterday, I've been in Golang Meetup in Philadelphia when I actually presented a talk called Refactoring to Modules. And we went through all the details of how Go modules work. And yes, they have proper versioning. It's done very elegant. Kudos to
Yeah, it's really
Russ
interesting in the talk that so.
Yeah, and that's a great talk. And hopefully I will come around again, maybe in trying to get to speak with Ashley to get to Golang NYC.
Yeah.
And I'll see you all there, I hope.
Yeah, excellent.
Yeah. Okay.
That's a tough one to follow.
Well, from start to finish, like how long was the process?
It's still ongoing. It's a huge project
Yeah.
because we also have a lot of code. Right, Artifactory, the first version of Artifactory, the open source, was actually released in December 2006.
Yep.
No, yeah, 2006. Wow, that's a long ago. So we have a lot of code, and the transitioning was not easy. A lot of work in the HA part, just because of what I explained, how HA is different. Artifactory for sure runs in Kubernetes now, and Go Center is a proof of that because we run Artifactory in Kubernetes inside Go Center. But there are still a lot of concepts which are not cloud native first, and this is what makes everything more complicated.
When dealing with persistence, is it possible to avoid the problem in the near term and just use like RDS
Yeah,
as
absolutely.
well as your? Okay.
So there are a lot of solutions. Obviously, persistency and state is on everybody's mind because in the earliest versions of Kubernetes, they pretended that persistency and state does not exist,
Yep.
and that was a fine assumption to get started, but obviously had nothing to do with the real world. And since then, a lot of solutions, both from the cloud providers, from Kubernetes itself, and from a lot of companies that do storage, actually evolve that solve this problem, right? And the solutions are different. Some of the storage providers, companies like, what's their name? Something, right? There's a lot of them. There's NetApp, there's Storage, IQ, I don't remember all the names. Some of them abstract this problem for you, and they say, you know what, write to the disk as you have this application installed on this computer, and we will abstract the entire management of migration of the pods and everything for you. The others use the concept of Kubernetes, like reserved data volumes and this kind of stuff, when you can say to Kubernetes provider, I need this disk, and I need it to exist whatever happens to my application. And then the Kubernetes providers take care of that. And
But it's more than just that, right? You have to do more than just define the store,
Yeah.
right?
Yeah.
Okay.
There are solutions for that, but obviously it's not as easy to pretend that state does not exist whatsoever.
Do you have some advice for tools used for the local dev setup if you're working with Kubernetes?
Yeah. So today it's very, very easy to do because Kubernetes now comes with Docker for desktop. So if you have Docker for desktop, you actually have Kubernetes running.
And if you have Linux, you do not.
As much, he's okay.
I'm okay. It's just about me now.
But yeah, you can install Docker Compose for Linux and Docker and
Yeah, there are other
shortages
solutions.
there.
There is Minikube,
yeah, many.
and there is something that is called K3S instead of K8S, and that's a Minikube from Rancher that is intended for IoT devices, but can obviously also run very well on your developer machine.
for like Raspberry Pi actually.
But it runs just great on your machine as well.
In
It
fact,
doesn't have
if you look at like AWS solutions for IoT, at least for a while, you could actually run a lot of things for logs and whatnot on the IoT services a lot cheaper than you could elsewhere. So I had all friends that would sneakily do that.
Yeah, no, actually, a lot of people run K3S or as their development environment alternative for Kubernetes, and with some differences from the full-blown Kubernetes, it actually can work very well as well.
And some other CLIs that you would suggest to use? Or
So there is Minikube, and there is
other useful tools?
I'd use Kubernetes on Mac and
Yeah.
Helm for your
Yeah,
for your
just
dev
works.
environment. And
Yeah.
Okay.
yeah.
Right.
Yeah. Well, what we actually do is we have we use Kubernetes for desktop, and the next stage in the pipeline already uses cloud providers Kubernetes, like separated clusters for development. Yep.
Another one is, where do you really see with people who do migration for the first time, where they don't go for opinionated enough options, just at different sections of running such an integration? So just wondering if there's parts where you say people usually don't make the right decision in going for a setup where they would be better off sticking to something that's more opinionated. So you said the managed servers go with that first.
Yeah. So I guess there are a lot of moving parts and kind of a lot of things to attend if you run Kubernetes on your own.
Yeah, it's a bit overwhelming.
And this is why that's the exact idea of don't do that.
Yeah.
Start with something managed for you. They will take care a lot of those greedy details of how you run it on your machinery.
Yeah. I've been defining my local dev environments just with Docker Compose.
Okay.
Which
It works. I mean,
It
in
works,
the
yeah.
end of the day, those are all containers.
Yeah,
Yep.
right, exactly. Yeah.
and they can move just as well to the next stage where I am running.
Yeah.
You need to remember all the limits and the probes and everything that you don't touch, you don't care about on your local machine.
Yeah.
And this is kind of the difference of, okay, I have my application running Docker, I'm all set to go to Kubernetes. Not really.
Yeah.
And this is what we always spoke about, your app is not ready, it's about that.
Yeah.
You might already run in Docker, but still not ready
No,
to
exactly.
run in Kubernetes.
Containers run different than.
It's not different. In the end of the day, those are containers, but Kubernetes does more that you need to be ready for. I guess that's the difference.